Hey YouTube, it's Dimitri, and today we're going to talk about curriculum reading and a list I'm going to be putting together. This will be a three-part series, 3 videos. I will link them all, so we'll put either like little tags up here or in the description. You can kind of link the 3 together. But this video is going to be talking about how and why I came up with a reading list here in 2026. And then we're going to have a video on the undergraduate courses / textbooks that I'd recommend for studying and getting into quant. And then the mastery PhD level. Again, focusing heavily more on the masters, but similar classes what you take kind of in your beginning portion of your PhD before you kind of get into a full PhD. But a PhD will differ quite a bit because you're tending to be a little bit more focused on things that are not quant finances, or there's not many quant finance PhDs. So this video again is intended for quants. That means model development, model validation, quantitative research, quantitative analytics. This is not a video. None of these videos are going to be for quant dev. So that's implementation, looking more at the hardware, the software, the computer science, computer engineering side of quant. Completely different area. It's not going to cover this. This is not for trading. Sorry. I think traders are business people. You can have quant trader. You're a business person that knows a little bit more how the models work and use quantitative tools. You're still on the business side of this, and this video is not going to cover that. So I made a reading list back in 2019. I think it's important to note that was kind of the end period of my individual contributor career portion of that when I made that video. I then started transitioning into a management role of running small teams as associate director. I went on to be a director in model validation and oversight for that, for model governance and the validation teams. And then I went on to build out a quant research, development and implementation team. I'm working also within the pricing and strategy department and kind of structuring that team for our fintech as well. So I'm looking at this now as a more well-rounded management, looking at multiple positions. And then of course, I've been networking and talking a lot with people on the buy side. So some of the biggest hedge funds out there, a lot of them actually come and chat with me about career development and career issues. And then I talk to them about the industry and skills they need. And then I've done program assessments as well and really got into the weeds on a really, really well-rounded process here. So that original list was more or less what I used to kind of patch my way through. This is more of a optimized, like if I had to do everything again, these are the courses / textbooks I would use to become a quant from the ground up here. And I think it's important to note there is no like best path or best route, especially when you look at quants and what quants do. So if you don't know quantitative finance and those that are quants, which is a slang term for people that do quantitative modeling. Quants are going to be those that are building new research and new models to solve problems, right? If you're going to be like taking a model off the shelf and just calibrating some parameters, you don't need a quant finance degree, and I wouldn't call you a quant. Many people might, maybe a quant analyst or I don't know, something like that. But you need to do something unique. You need to be cutting edge. You need to have some sort of new approach and generate new ideas and new ways to solve problems, right? So to do that, it's hard to say like, hey, everybody takes the standard path and this is going to be the best path. The best quants, as you'll see, often come from a very, very wide array of backgrounds, from math to stats to economics or econometrics, physics, for example. Like there's just a slew of these, but I don't go out and say, hey, like go take some obscure path, like, I don't know, go get a PhD in like topology and this will end up in quant or quant dev. Like, it's not the best path. Like this is going to be the most common path. And you'll see here too, a lot of the skills here that I'm just going to briefly cover in this video are things that are good foundations. Like the goal of this coursework and these books is to build the solid foundation to build a successful quantitative finance career. So some of the limitations and things I thought about when putting this together is going to be like, how many courses can you realistically take in an undergraduate degree here in the US? How many courses can you realistically take in a graduate degree in the US, right? I think there's a lot of things missing, things that are critical, things that are important, but they're not the core foundational principles. They're not the things that would prepare you as well as the ones I'm going to be listing here. And again, it's a limitation, right? You can't take every possible course under the sun. When I graduated from my master's degree, I was like, like there's all these other courses and other departments I'd like to take classes from. I just didn't have the time. And so that's what this list is going to be, is a realistic view and understanding of the core foundational principles and things I think that are unique that you need to succeed as a quant here. So let's just dive on in quickly. The undergraduate courses, one should prepare you mathematically for mathematical maturity. You're going to need Calc 1 and Calc 2, linear algebra, ODEs, PDEs, and of course, probability. Often it's a probability and statistics course baked together. These are the core courses just for foundational skills. They are also going to be the ones that prepare you for a graduate degree. So most quantitative finance masters, statistics masters, econometrics masters, like a lot of these masters that are going to lead you into a quantitative finance career are going to require Calc 1 and 2, linear algebra, ODE, PDE, probability. That's just the foundational pieces of that. And then to top that off, I think it's important to have econometrics and an introduction to machine learning class as well. I will note as well, graduate programs that are teaching undergraduate level courses, I don't look quite highly on. I don't think you're doing a big service to your students. Even if your students are coming from like an engineering background and you're teaching finance at an undergrad level, it's not really a master's degree. Like you're kind of cheating them on the value there. And perhaps you're bringing in the wrong quality students. So those students might feel like it's a great program and they rant and rave about how amazing that program is. But I'm just telling you up front, I would have econometrics and introduction to machine learning as those are critical skills to build. When you get into the graduate level, specifically for machine learning, you should be doing graduate level machine learning work. And you should have this solid foundation of mathematics to really hit it hard and get a bit more rigorous into why things work, why they don't work, and how to apply them and selecting models and all that. The other courses here that I have is going to be investments, microeconomics, introduction to Python programming, and economics. You will notice throughout this, there are a few classes I have no book listed. Like I just can't find the perfect book, like a book that I think is a really good, solid foundation for that. And Python programming is one of those. I will note, I have like Lutz's book, L-U-T-Z. It's this purple book right here I'm pointing at. It's a really thick one and it covers a ton of stuff in Python. But it's too big, it's too computer sciencey, it's too quant dev, it's too software engineering. It's not great for quants and like just getting into the meat and doing more or less like Python scripting and that model development and research phase of that. I've gone through a handful of other Python books. If you guys have recommendations, like put them in the description. I'd love to go look at books and see if I could find something great for some of these ones I have, missing. I have no book for. But understanding economics, I think, provides you a unique perspective of quantitative finance, of markets. I think it's very odd. There's a portion of the quant community that has this disdain for like economics, like, oh, it's not real quant. Economics is like the original quant. Like if you guys don't know, like even like Fisher Black was a mathematics PhD, went through that process, and he fell in love with economics and applying math and stats to financial markets. And it's a lot of people's stories in general. Economics though gives you that macro view. Understanding micro helps you understand like interactions as well. I don't have it on here, but I do have it as an elective down here on the bottom, which is going to be game theory. If you get into HFT, for example, understanding what players do and optimal strategies and all that, that gets into game theory. Interesting process, but not one of the core foundational principles here. But anyways, economics and microeconomics and econometrics plays a critical role. I do have an economics here class listed, but it is a mathematics for economists. It covers what I would consider like a great level of, very advanced course for undergrad, but really prepping you for that master's degree of looking like at optimization problems and some calculus and things, but applied more to an economic finance setting. So it gives you more of a real world flavor. And then of course we have investments, trying to understand a little bit more of that market as well. But again, the goal here is not to specialize in buy, sell, wealth management, like any sorts of these different types of pockets, securitizations, derivatives, anything like that. It's just to get you the core foundational skills you need here. I will note there are some interesting electives that I would encourage and recommend students to take. Many of these I had in the core courses, but I tried to keep this list down to about 12 courses. And I heed and hawed, and I was like debating with myself over like about a month of trying to figure out like, what classes are really needing to go into that. And I don't want to tell people to take everything. And I also don't want students to try to take like the hardest classes possible when you could take some easier classes and focus in a different area of quantitative finance and not go through that path. One of these is actually studying stochastic calculus as a mathematician. And so, for example, two of these classes was like real analysis. So looking at real analysis 1 and 2, those are foundational. Like you need those to really understand this process. And to get on the tangent here, if you wanted to go into actual financial engineering of derivative products, not just understanding the general Black-Scholes and some jump diffusion and a simple, process of American options and a few other things, you would need to go through analysis 1 at a minimum. You would need measure theory as well, and then you could jump into stochastic calculus, and that would be on these other electives here in the graduate program, in like the Klebanair's book, which is actually like a math book. It's not going to be a finance book. So Klevener's book, let me just talk about this briefly. I really enjoy it. It's a much deeper, more mathematically rigorous proof process of going through the material. He gives examples in biology and in finance. Oddly enough, I think the biology examples to me make more sense. They're clearer to understand. Finance always has a little bit of a, I don't know, hand wavy. There are lots of externalities that are impacting these pieces here. Same with biology, but biology for some reason just hits closer to home for me. Maybe it's because it's what I studied in my original undergrad. But anyways, there are other classes in here I think that are important to take. Again, mathematical statistics I think is critical because that's going to be like an introduction to more of a rigorous proof of statistics. You will cover that a bit, but at an undergrad level again, on Wooldridge, and as well as this economics course and some machine learning and the probability and stats class here. But anyways, these are some options to take. Understanding things like C++ and C#, again, would be more focused on someone who wants to do more quant dev, or you're kind of between the middle of like, I don't know if I want to do quant or quant dev. Like understanding C and C#, even if you don't use them on a daily job, like that's what I built my foundation on, of understanding how programming works. Anyways, I think it's an important piece as well. There are other things like corporate finance as well, which I think are kind of interesting. And again, you can keep going with calculus and optimization. Corporate finance itself, though, will just give you a more broader understanding of how products are actually used in the quant finance space. And I would highly recommend you guys don't poo-poo the finance classes. I know it's typically a GPA booster, and you'll notice here, like, we don't really have that many of them, but they do help you understand the broader big picture. And as you do things as a quant, even if it's highly technical, understanding a lot of those business intricacies and legal contracts and things that tie into stuff, it makes your modeling much, much better. So I would encourage you to also kind of be well-rounded in that sense. Now on to the graduate one. Again, we had the same kind of issue here of trying to keep this down to a reasonable number of classes. I just pretended these would be like 3-credit courses. Again, 36 credits, about an average of a master's degree. And you'll see some of the classes here I'll list in the electives are things that are more specializations here. Again, interesting classes I either took or wished I took, or things that are very specific to different areas, which are exciting, but they're not going to be the core function here. So one thing I'll note, I have stochastic processes. I do not have stochastic calculus. As I was pointing out, I think derivative pricing is an interesting area to be in. I think it is way overhyped. I think historically that is a lot of the quant finance community kind of spun out of that as data was available. More math theory was applied to it, and econometrics was actually applied, like even using like financial theory, like the CAPM, and driving through that, how Black-Scholes came up with that. I think it's an interesting class, but I think it is far more useful to understand stochastic processes, and there's just a limitation on how many classes you can take. So I have derivative pricing with Shreve's 1 and 2 books as interesting classes to take as electives if that interests you. But stochastic processes, really getting into like Markov chains, for example, I think in some other time series applications are important pieces to understand at a fundamental graduate school level. Financial statistics, machine learning in finance, time series in finance are all going to be modeling based. Like that's just modeling, like machine learning and using stats and time series. They're all just types of models that we would use in that space. So understanding those at a graduate school level, you'll notice the textbooks here tend to be about a grad school level in general, trying to get more rigorous, understand the ins and outs of these sorts of models and how to actually do this in practice. And then numerical methods for finance is a useful tool set. So I thought a lot about this. Glasserman's book down here for Monte Carlo simulations and the electives, it heavily focuses on Monte Carlo simulation, but there are other tools and things that you can use. And so I thought numerical methods for finance is a more general premise, is a more useful class for tools, which is why that was selected. And then storytelling, data, and plotting, I don't have a textbook for. In a career, the difference between great quants and mediocre quants that are just kind of floating along are those that can actually build models, create a story, sell that model to the business so they really have buy-in into it and they love that model and they want to use it and they have great faith in it. I've built extraordinarily complex models that have done amazing things and met all the requirements the business wanted, and then we couldn't explain them. That creates a lot of issues. Often it's better to kind of miss a few of the requirements from the business side and explain like, hey, this is super simple and easy and this is how you can kind of patch the things you wanted. I know. As a quant, it kills me inside. My soul dies a little bit when I have to do it. But understanding, again, how to do data, like merging, processing, putting things together, understanding intricacies with data, properties and characteristics of data, handling missing values, all that sort of thing. And then plotting. Like I've had many cases in my career where I wanted to like, for example, like a yield curve. So you have like the interest rate for 6 month, 1 year, 2 year, 5 year, 7 year, 10 year, 30 year. And I've had a model that shows kind of the steepening and flattening and all the different characteristics of those curves, but I have to have multiple curves in time to show that. And so while I've sat and coded this out and I've looking and done a bunch of analysis, it's hard to convey that. So being able to do a good storytelling process with that, and then being able to automate charts and do like automation within the plotting framework, so you can kind of see like a really dark line pops up, and then the automation shows the new line is the dark line, and the old lines then go to a faded color, showing that movement, and then adding like an arrow on the screen so you can be like, oh, the curve itself is flattening over the last 12 months. We're really seeing, this sort of trend and drive within the business, and these are the decisions that need to be made. Again, plotting. I have not found a great book for that. I searched, I've looked. There are books, but I haven't found anything that I think is amazing. If you guys have any recommendations for Python or even R, for example, put them in the comments below. I'd love to see that. That'd be a great kind of tool, I think, to add out on this book reading list here. And then other non-traditional classes I have are going to be risk management and model development and model validation. Model development, model validation, I imagine this as a course where you would see a group of students building a model and a group of students validating a model. It might have to be like a 2-semester trade-off where you swap, so you have something to review and work on. But doing model development, going through all these courses, you've already built out a bunch of models in your undergrad and your grad, but how do you do this in practice when somebody gives you like an actual assignment? Like when the business, the trading team, the operations team, the pricing and strategy team comes through and they said, hey, we need a model for this, go build this. Going through that full process and filling out model documentation and writing out, even if it's just 20 pages, the 20 to 30 pages of documentation on how you went through that process, the issues you found from a model development standpoint, and then going into validation, looking at the tests, reviewing the work here and going through that with a fine-tooth comb. This is what we do in practice. Like this is the real job here. You can simulate this in a coursework. Again, I don't know what book I would do for this. There's somebody that reached out to me recently, a professor who's working on a book that's going to be releasing on model validation. I don't know. I think it's an awesome idea. I would love to write a book on it. But getting into the nitty-gritty quantitative sides of when tests fail and what's the consequences and how do you understand these in the perspective of the business, that's what this course should cover. But again, I have not seen anything on that. And then risk management. So there are some books out there. I think there's one right here. It's Quantitative Risk Management. I think the book is not great. It's just not, it doesn't cover what I would consider risk management. And risk management is really the stats, modeling, math, and the governance, application, business use, model monitoring, like all these pieces tied together. Like think about it as like a business on steroids. Like you're really trying to get out great optimization and accuracy and pieces here, but also looking at the risk stance of like, how is this model going to fail? Why is it going to fail? How do we have backup plans? What do we do in these sorts of scenarios? And then how do we look at like market, credit, operational, regulatory risks all together? And you can break out liquidity risk, and you can break out like a bunch of other regulations and reputational damage and risk like that. And yes, there are models behind a lot of this in practice. Some of them are not models. Going through risk management on a full, deep, rigorous level is important. Too many classes that are risk management do the investing side, and they do really, really dumb, simple things like, oh, value at risk. Great. But like in practice, when that portfolio blows up, like what goes on in the firm and what do you do when the model fails? Like no one talks about this. This isn't included in these classes. That's real risk management, and risk management is really a generalized principle of quantitative finance. Like quant finance is risk management in an application here. So again, I don't have a textbook for that. I would probably have to patch together a lot of different topics and pieces and experience of mine with textbooks to make a course on this. But if you can find a risk management class and you can learn some stuff there, I think it's an important class to take, even if it doesn't cover it the way I would go through it and cover it. And then finally, financial products and application for strategy with this. The big John C. Hole book, the options, futures and forwards, whatever the book, the big one, not Baby Hole, but the big book. I think understanding the product strategy and how they're used is important. Again, if you would have taken the corporate finance class down here with the Ross textbook, they start to talk a little bit about, like, for example, how to use derivative products and how to create like a butterfly spread and why that's important and what's the strategy behind that. But trying to find a class that has that sort of application, I think is important as well to really understand what you're going to be modeling. And then finally, econometrics. And yes, you're required to take that as an undergrad on the left side over here with Waldridge. The book by Hayashi is going to be at a graduate level, understanding more of the nuances of the estimation, the calculations of like coefficients, for example, and model tests, and getting more into the weeds on that is important. So when I worked in model validation, that was my job. Like I would nitpick and be like, oh, this test was invalidly used, and there's a bias within this estimation. And so thinking about this from a business perspective, like this is not a good thing to do, and this is how I would change the model, and this is why this is an issue, and going through that process. Understanding econometrics is important. Speakers and reading seminar. So many programs have a speaker seminar. Congrats. Speakers can be great. Speakers can be awful. Many students probably can relate with that are in these grad programs. But I also think you should, on top of that, besides getting an industry perspective and some stories and some career journeys, I would go read a book. Go read a book. Not a textbook. Go read like a book by like Emmanuel Derman, Fisher Black, Milton Friedman, even like economics. And you could use one of those other trendy ones like, The Black Swan, or like Models Behaving Badly by Emmanuel Derman. I think it's a pretty good book as well. It can even be like My Life as a Quant by Emmanuel Derman, some of like the life books. I think reading and seeing others' perspectives on quantitative finance is important for really understanding your role in the ecosystem, and understanding other issues when you're a student, because you're just missing all the experience. And having a deeper understanding, again, in the risk context up here in a risk management course, but also doing a book report like we were in elementary school again. I know it sounds ridiculous, but I think it's an important piece here to spark your interest, get you going, and help you interview better in that process. And then finally, having a capstone course. And I don't have it on here. I wish there was like an interview course and an interview class and everything else, and communications class. Many programs have them. I'd highly recommend them, but I don't really have it here in the core courses. But I think a capstone course is critical to actually bring all of this together to do a project so you can understand the skills, do a little bit of like a research. Like, this is a problem I came up with. Going through all these classes I took in grad school and the skills I learned in undergrad, how do we put all that together to come up with a solution? And as part of the capstone course, you should be checking in and presenting to the class as a small group. So like groups of 3 typically have like a math and stats person, a computer programming, like a computer science student, and like a finance student in a group. And you should be presenting to the class. Like every group should be rotating through. So it should be like, a month or so between presentations. And you should come in and say like, oh, this is where we're at in our project. These are the hurdles we're running into. And then maybe some other students can throw ideas out there, come up with some sort of thing, write an actual like model development document or a research paper. Research paper would be better in this case. So model development was above, but doing more of a research paper, struggling and wrestling with an idea, using quantitative tools and methods, and bringing everything together will help build out the resume, because you have something interesting to do that took you an entire semester, or maybe you do it over a year. Different programs do them differently, but really getting all that put together. And of course, I don't have a textbook for that, but I think it's an important thing to note here if you're going to be doing curriculum and doing a master's here. Again, let's just quickly go through the electives I would consider. We talked about communication. Again, AI and finance with applications. I have 2 of these. So I have a book up here in the core courses. This one is more rigorous. This is more grounded and more generalized. The AI and finance with applications, there's a book called Hands-on AI Trading, which, yes, my name's on the back of the book. I wrote a review for the book. But I think the book does a great job at using Quant Connect. So Jared Broad is a friend of mine, CEO of Quant Connect, and they help you, Quant Connect itself is the software and builds in like the piping and getting models automated from that to the exchange to do the trades, and then, execute back and forth on that. More of the quant dev work. That first part of the book, you can, like, if you enjoy that and you love that, quant dev's for you. This is a good book for deciding that. The back half of the book is really simple machine learning models and tools, but applied to a lot of different small problems on the trading and investing side. And so I think it gives you an interesting perspective and insight on how real world problems could be here. So again, interesting one. Linear modeling, getting more into the weeds with linear modeling. I know everyone thinks like, oh, I took like OLS regression and I've done like weighted least squares and like I'm done. No, there's a lot more to digging into that. If you want to do equities, so like factor modeling and factor investing, understanding linear modeling is a very, very important piece. Understanding the time series as well is an important piece that falls into this, and you can get more in the advances of that. Panel data modeling, again, just a different specialization. I've ran across it a few times in the credit side with panel data modeling. I never had an official class on it, but it's an interesting topic to really get into the weeds on. Monte Carlo simulation, as we mentioned, deep learning for AI and finance. I don't have a book for this. I haven't seen anything great at the graduate school level. There is the book by Chalet, which I really do like. It's a great introductory book. There's also a free book on my website as well, which I used when I was having to build out models and get into the weeds on it. And I always like free resources, but it's a quality book. It's like rigorous and academically derived. That's the book I would recommend, is probably that one on the website. And then advanced time series, you get into like Hamilton, which I have his book, I believe, like somewhere in here, one of these big, really thick books. Hamilton just takes a very rigorous math approach at time series. And so if you want to specialize in time series or any of these other elective areas, your elective should help you kind of focus in on something that really interests you or you think that would be interesting, because you probably don't know. But pick something you think would be interesting and dive deep on that. And then you have market microstructure for the HFT side, and that world understanding the trading execution sides. Credit modeling would be more on the banking side. It is an enormous job market out there in credit modeling. I churn through hundreds and hundreds of resumes because a lot of my career has been on credit modeling, like mortgage, auto, credit card, those sorts of products as well. And then again, if you wanted to get into derivative pricing, if you're wanting just to understand it better, and most programs have this as a requirement anyways, but I think Stephen Shreve's books 1 and 2 are a great introduction on discrete time and continuous time, using binomial trees, and then moving into a continuous framework with stochastic calculus. It gives you what you need just to get to the derivative pricing, but it's not going to get you into the weeds on like other unique problems and issues you kind of run into with stochastic calculus. If you want to do the more of the advanced parts here, advanced stochastic calculus, Klebener's book I have is great. There's also an exercise book which he sent me, and I haven't had time to really go through too much of it. But it gives you just more examples and really gets you deeper into the weeds. So I think using Klebener's book to get going on that, even if you just do that as a class or you just read it on your own for self-study. But again, I'm going to tell you, take analysis, take measure theory before you dive into that. Because I've had students say, hey, Dimitri, about that book you recommended, I didn't understand like any of it. It's like, well, it's for someone who's mathematically more mature on that spectrum here. And we have all these skills, math, stats, finance, and everything. So anyways, if you want to get that in the weeds, Klebener's book is great for that. I hope you guys enjoyed this video here. I hope you guys see the struggle here. Like, there's lots of interesting topics, and there are entire topics I didn't even list. Things that are, electives, other core courses that would be interesting to take or more, qualified or something like that in your mind. But this is how I would structure a reading list. This is how I'd structure your education. If you're coming from an international perspective or you're coming from a US school, I hope this list on these 2 videos, as we break down the actual textbooks, I will break down more of the content in the textbooks as well. Because I think it's important to say, like, just because you used a really rigorous textbook doesn't mean you learned a lot, or doesn't mean your class was rigorous, because how much of that textbook did you cover? Did you spend a lot of time on 4 chapters and really dig deep, or did you cover 25 chapters in a semester and you barely covered anything in any chapter here? So anyways, that is my take. That is my explanation and process of this. If you like this, don't forget to look at the other 2 videos I'll put up above here or put in the description below with the actual textbooks listed out and a bit more of the table of contents and topics I think should be covered. So anyways, thanks for listening. Thanks for watching. And as always, until next time.